The CLO for this lesson is that students will be able to create, in writing, quadratic equations using graphs, tables, situations, and key features, as well as the following language: if-then statements, quadratic, parabola, x-intercept, y-intercept, vertex, horizontal stretch/shrink. In your own words, what do you think you're going to learn how to do in this lesson? Right, so let's talk about the vocabulary quickly, because you should know what most of these mean. Go ahead and tell me, what's a quadratic? All right, so what's the definition for x-intercept? And then what's the definition for y-intercept? And what's the vertex? This one's kind of new. It's called a horizontal shrink/stretch. And I'm going to show you what it looks like. So let's say I just have x squared. So this is the basic x squared graph. So I'm going to come and I'm going to take it again in a new color. Now it's there in blue. It's also in red if I make the blue go away. But horizontal means side to side. And stretch/shrink, let me show you one of them. This one with the 3 in front made it shrink. Think of it as if on the red one, because the red one was the original. Imagine having someone grab each side of the red one and push it in. It's like they're shrinking it in, like smushing it together. And it got thinner and it goes up quicker. Versus if this isn't 3, like let's say it's a fraction, like 1/3. Now do you see how it's like they took the red one and pulled it out? They stretched it out and made it fatter. So if there's numbers in front, if there's an A value in front, it will do something where either will smush the graph or stretch it out. Which is why it's called a horizontal shrink/stretch. And what it is when there is an A value in front of the equation, it causes the graph to get, and if it's shrinking, it's getting thinner, or if we're stretching it out, it's getting fatter. It's a new key feature that we are adding. So before we only cared about these 3 key features. Now when we're getting the equation, we also care about the horizontal shrink/stretch. All right, so in math, there are many competencies that you have to prove mastery on in order to graduate. One of the competencies is being able to pull out key features and also to compare them to each other, which is kind of what the next lesson's about. But another competency is to be able to go between all 4 representations in math. For example, there's a few of these we already know how to do. For example, if I have a table and I want to get a graph, it's really easy. All you do for a table to graph is plot the points. If you have a table, you look at it, you put them on the graph, and then you connect them. You need to correct them to the correct shape, depending on what type of graph it is. But in this case, it's a parabola that you're going to always make. So we know how to do one of them. If I'm at a graph and I want to go back to the table, honestly, all you do is you, so graph, to table. Pick some points on the graph and write them in a table. So like if you're looking at any graph like this one, you can just pick a point right here, and then you'd write -1 in the x place and +1 in the y place. And then maybe you could do this one, and you just pick a couple points on the graph and you put them into the table. This connection's really simple. If I want to go from an equation to a table, like if they start me with the equation, and I need to come up with a table. All I do is I'm going to pick some x values, pick x values, to plug into the equation and find the y values. Write them in a table. So once you have, like, for example, if you plug in an x of 2 and the equation gives out 5, then you'd write it in a table where the 2 goes in the x spot and the 5 goes in the y spot. And then you do a couple of them to make a table. Also, if I want to go to an equation to a graph, well, that's what we learned how to do in the last 3 lessons. Where if I gave you the equation in any form, we use the key features. We find the key features really fast, and we use those to create a good graph of it. So for quadratics, the last 3 lessons were about how we go from equations to graphs. Everything else, all of the other connections, we're going to learn in the next 2 lessons. Today's lesson, we're going to learn all the ways to get the equation, because it's about getting the equation. So we're going to learn table to equation, graph to equation, and situation to equation. Today's lesson is all about how we get the equation. So here, I'll do today's in blue. So we're going to learn how to get the equation from all 3 forms. And then tomorrow, we're going to deal with all the situations. So besides situation to equation, which we're doing today, tomorrow I'll show you how to go from an equation to a situation, a table to situation, a graph to a situation, as well as going from the situation back to the table or from the situation back to the graph. Equation to situation, situation to table, table to situation, graph to situation, and situation to graph. So this is mastering this competency was a big part of this whole unit, is learning how to go from all of them, which is why in the last 3 lessons we focused on this one, and then we're going to focus on the rest of them in the next 2 lessons. So let's review what we've learned so far. So far, we've learned the equation to the graph. Remember, for all of them, to get the graph, you're going to start by getting the 4 key features: vertex, y-intercept, and the x-intercept. There's 2 of them. So this is, we're not going to do it. It's going to just be a quick review of how to do it from each key feature. So if I'm in standard form and I want to get the x-intercepts, I use the quadratic formula. For 2 answers. And then don't forget, then it's comma 0, whatever your 2 answers are. For the y-intercept from standard form, it's going to be really easy. It's just going to be 0, comma, and once you plug in 0, the answer is always going to be this c at the end. So it's just 0, comma, c. This is the fastest one for standard form. It's just 0, comma, the last number. It's really fast. For the vertex from standard form, remember to get the x value. It's this little equation that says negative b over 2a. And that's the x value. And then the y value. That's how you'll get all 3 for standard form. For vertex form, to get your x-intercepts, you use backwards order of operations for 2 answers. Then it's comma 0. Get the y-intercept, it's going to be 0, comma, plug in 0 to find the y value. You just put 0 into the x and then solve to get the y. And then for the vertex from vertex form, remember you're going to make the parenthesis equal 0, and solve with the x. And then the y value for the vertex is just this k at the end, whatever that k is. So this one is known as the fastest one for vertex form. Because it's really easy to make this parenthesis equal 0 and solve it. It's really fast, and then just comma this guy. So this is the fastest one for standard is the y-intercept. The fastest one for vertex is the vertex. The fastest one for factored form is the x-intercepts, because all you do to figure out the x-intercept is make each parentheses, both parentheses, equal to 0, and solve for the two answers. And then it's comma 0 at the end. So this is the fastest for factored form. Is to just take each parentheses, make them equal 0, solve it real fast. That's the fastest one. This, to get the y-intercept, you plug in 0. So the x is 0, and to get the y, you plug in 0 for both x values and solve to get the y value. So that's how you figure out the y-intercept for factored form. And finally, to figure out the vertex for factored form, the x is the middle of two x-intercepts. It's for the y value, you plug in the x you found and solve for the y value. Remember, to get the middle of, you can add the two x-intercepts, then divide by 2 to figure out what the middle of them is. This little chart is really useful. I would make sure I had it written down to use on the test. So let's talk about how we create the equation. Here are the basic steps, and I'm going to show you a ton of examples. So step 1, you're going to pull out all the key features you can. So if you're in a graph, table, or a situation, you're going to try to pull out every key feature you can. You don't know how to pull out the A yet, the horizontal stretch, but you can try to pull out, you can figure out if you can find the x-intercepts, the y-intercepts, or the vertex in these things. So that's step 1. So we're going to do step 1 for all 3 first. So I have a couple of examples. This one's a graph. So I'm going to start with pulling out all the key features from the graph. So x-intercepts. I look at this graph. Where is my x-intercepts? There's 2. There's this -1, 0, and this 3, 0. So I have -1, 0, and 3, 0. And the y-intercept, where's the y-intercept on this graph? It's crossing y right here at 0, 3. Finally, the vertex. Where's the vertex in this graph? Well, the top of the hump is right here at 1, 4. And this time around, I showed you what the points were, so you can read them. But know that sometimes these won't be here, and you just have to be able to read the graph and know that this one's -1, 0, for example, or that this one's 3, 0, so on and so forth. So that was step 1 for this one. This is my table example. Let's see if we can pull out all the key features in our table. So x-intercepts. Where are the x-intercepts in the table? Remember, x-intercepts are where the y value, the f of x, equals 0. So I only see one of them right now. Do you see this? This is the only one here. 1, 0. So remember to just pull out all the ones you can, because they're not going to always give you all of them. What's the y-intercept on the table? Remember, y-intercept is when x is 0. So if I look where x is 0, that's this one right here. So that's at 0, comma, negative 2.5. Where is the vertex in this table? The vertex is always slightly tricky because you have to look at the y values and you have to see if you can find anywhere where it peaks in some way and then goes back to the same number. For example, in this one, if you look, this y is negative 4. Then it's negative 4.5. Then it goes back to negative 4. So this point is where my middle is going to be, my vertex, because on each side of it, it's the same. So my vertex is negative 2, comma, negative 4.5. So if I wanted to, because of the symmetry rule around the vertex, I could figure out my other x-intercept in my table. And here's why. If this is my middle, and I go over 1 on each side, I'm going to be at negative 4. If I go over again on each side, I'm at negative 2.5. So if I were to add a point here, going backwards one more on the x's would be at negative 4. And then my y has to be the same, has to be symmetric at negative 2.5. So each one, the x's are going up 1, are down 1. So then if I were to go again, the next x is my x-intercept. So when x is 1, my y is 0. So if I go backwards another one on my x's to negative 5, because the y values have to hold symmetry, the next one has to be 0 as well. Meaning that my next x-intercept will technically be at negative 5, comma 0. So in a table, if you know where one of the x-intercepts is and where the vertex is, you could keep going in the other direction to figure out where the other x-intercept is. But you don't have to do that. You don't have to do that to get the equation. You can, so it's a cool trick if they want to know what the other x-intercept is. Like, you could always figure it out, but it's not necessary to figure out the equation all the time. All right, so I pulled out everything I could from my table. This is my situation. Step 1, where I pull out all the key features that I can. X-intercepts. So here's the thing about x-intercepts when you're having situations. In a situation, it is most common that x is time. And x is like how much time has passed, usually. So in situations, x represents time usually, and y represents amount, usually. Really, it's that x is independent. Time just exists by itself, like hours go by, days go by, time just exists. And y, the amount, is usually dependent on how much time has gone by. So like how much money you have depends on how many hours you work. So usually x would be the hours and y would be the amount of money you have. So let's talk about this situation we're in. Linda's standing on a football field at the 2-yard line. So let's look at a football field. So this is what football fields look like when they play football. They count by tens. And so since they count by tens, each little tick mark is worth, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 little tick marks between each 10 and 20. So if I'm on a football field, let's say I'm starting at the 2-yard line, that would only be the second little tick mark in. But she's standing there. And then she kicks the ball. So the ball's on the ground. And then it's going to land on the 10-yard line. So the ball is going to shoot up and land at the 10-yard line. Here's what we know so far. So far, we know at the 2-yard line, the ball's on the ground. We also know at 10 yards, the ball is also on the ground, because that's where it lands. So the next piece of information says the maximum height the ball reaches is 4 feet high. And the ball flies along a quadratic path. That just means they're telling you it's a quadratic equation, meaning it's going to make the parabola shape. So again, if I were to look at my football field, let's say I'm standing on my 2-yard line, I kick the ball, and then it lands on the ground at the 10-yard line. I know it makes this parabola shape. And then the maximum place, the highest it gets, it tells me is 4 feet high. So I don't know where exactly it's going to be 4 feet high, but I know that's the top, my hump, my vertex. My maximum amount is going to be at 4 feet. So at blank yards, we don't know. The ball is at the highest point of 4 feet high. Okay, so here's what we know so far. Let's try to put it into more mathematical points. So in this situation, what's x? Which one's the time piece or the independent piece? In our situation, the x happens to be the yards, the football yards. So it's not quite time. It's more like the distance of where she's at. And then the y, the amount is, what's the amount? The amount is the height off the ground. So depending on where the ball is, that will change the height. Because if it's at 2 feet, it has no height. Then it goes up, 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 and then it starts to come back down. And at 10 feet, it also has no height because it's on the ground. So if I were to write at 2 yards, the ball's on the ground as a point, it's saying at 2 yards, the ball has no height. So the x is 2, and the y is 0 because there's no height. Also, at 10 yards, the ball has no height. It hits the ground at 10 yards. So in our situation, what type of points are these? Is it the x-intercepts, the y-intercepts, the vertex? These are my 2 x-intercepts. So in a situation, if you're trying to find x-intercepts, for x-intercepts, you want to look where the amount is 0. Because for x-intercepts, y is 0, and y just means amount. So we had to look to where our amount was 0. When we had no height is when the ball's on the ground. Therefore, those are my x-intercepts for the situation. This one, is it my y-intercept or is it my vertex? Because it's talking about the highest point, it's going to be my vertex. So remember, again, vertex is going to be where it mentions either the minimum or the maximum. Minimum or maximum. Meaning if they're going to say anything like it has a highest point or a lowest point, or they have the most amount or the least amount, anything that signifies it's the most or the least, the minimum or the max, that's going to be your vertex. So here's the thing about the vertex, if I want to write it as a point. I know the amount, the highest amount is going to be 4 feet. I don't know where, though. However, because parabolas are always symmetric, wherever this vertex is, that's going to have an amount of 4, It's going to, no matter what, be right in the middle of these 2 points, always. So if I go right to the middle on both sides, if I go over and over, you see the middle is right here at 6. So my vertex is going to be at 6, 4, because it's right in the middle of my 2 x-intercepts. However, if I didn't want to graph it like that, remember, if you know the 2 x-intercepts, you can figure out where the vertex is by adding them up and dividing by 2. That's always true. So I could add my 2 x-intercepts up, the one that's at 2 and at 10, and I get 12. And then if I divide it by 2, 12 divided by 2 is 6. So that's another way to figure out that 6 is where the x value is. And then thankfully for this one, they told you what the y was. They told you it gets up to 4 feet high. And then they don't tell me anything about the y-intercept. The y-intercept in a real life situation, the y-intercept, if x is 0, that means time is 0, meaning no time has gone by. So when no time has gone by, how much do you start with? So for example, if this was a situation about money and I said, like, I just realized that I'm in debt $1,000, then my y-intercept would have been, at no time, I'm in debt $1,000. So I'm negative $1,000. However, in this situation, when x is about how many yards you're at, because we're saying x is the football yards, you're starting at the 2-yard line. You're not starting at 0 yards. So, like if you imagine connecting this graph, it's going to go down and its y-intercept's going to be negative. The ball's not going to actually be underground. It's just, this is one of those situations where the y-intercept doesn't matter to our real life situation because we're starting ahead of the y-intercept. We're starting at the 2-yard line. Step 2 is use the x-intercepts to put it into factored form, or use the vertex to put it into vertex form. So here's the interesting thing. Factored form, see how you can solve for the x-intercepts really fast? It's the fastest one. That means I could use them to make factored form too. Just like, since the fastest one for vertex form is the vertex, I can use the vertex to make the vertex form. The only thing I can't do is using the y-intercept to make the standard form. It's not enough information for me to actually figure it out, so I can't ever quickly make standard form. But I can quickly make vertex or factored form depending on what they give me. So, for example, for this graph, I know both the x-intercepts and the vertex. So I could do it both ways. Why don't I do it both ways? So to do this step 2, I'm going to either use the x-intercepts to put it into factored form, or use the vertex to put it into vertex form. Well, I have both the x-intercepts and the vertex, so I could pick either way. It doesn't matter which way I do it. I can pick either way. So let's say I want to use the x-intercepts to put it into factored form. Let's talk about how to do it this way. If I want to use the x-intercepts to put it into factored form, remember factored form always looks like this. A times x plus some number times x plus some other number. And when I make this thing, the x plus the e, equals 0, when I solve it, I'm going to end up with one of these 2 answers. Meaning when I solve it, I'm going to get something like x equaling -1. So if that's the case, if plugging in -1 for x will make it equal 0, what does e have to be in the equation to make it equal 0? Well, I could always solve it by adding the 1 over to find out that the e has to be positive 1. So in my equation, this e has to be a plus 1. So that when I make x plus 1 equals 0, it'll give me out the negative 1 as the answer. So for this one, if I want to be able to plug in 3 to the x and get out 0, in the equation, this has to be minus 3. So what ends up happening is it just becomes the opposite of what's ever here. If this is a minus 1, this becomes a plus 1. If this is a positive 3, this becomes minus 3 in the equation, so that when you make it equal 0 and solve, you end up with these two answers. So this is one way to start it. Another way to start it is I could use the vertex to put it into vertex form. So if I grab the vertex, remember that vertex form, and to get the vertex out of this guy, you have to make the parenthesis equal 0. So x plus h has to equal 0 to get the x value. To figure out the y value of the vertex, it's just the k at the end. Meaning, if I have the vertex and I want the equation, if the y value of the vertex is just that k at the end, I could just replace that k with the 4 because it's a positive 4. So I write plus 4 here. In the parentheses, remember x plus h has to equal 0. So right now, they're saying if x is 1, then in the equation, it needs to equal 0. So again, what does h have to be? Well, it has to be the opposite of that one. It has to be the negative one. So in the equation, the h is minus 1. So that when I make this equals 0, I get out positive 1 as the answer for the vertex. So again, it just ends up being the opposite of this, going into the parentheses, and then this one stays the same when I'm writing the equation. So the x value really is opposite of the h. So then if I go up to step 3 says use any one of the other key features to check if there's a horizontal stretch or shrink. Here's my equation so far in factored form. And then here's my equation so far in vertex form. So remember, these are going to end up being the exact same equation. I now just have to figure out, is there an a in front for this specific one? And to figure that out, you have to use one of the other key features. So remember, this is always y equals or f of x equals. It doesn't matter which one I put for an equation. So here's how we're going to test it. I can take any other point for factored form. I can't use the two x-intercepts because that's what I use to make the equation. So for this one, I can use vertex or the y-intercept. I'm going to go ahead and just use the y-intercept. So the y-intercept in my situation says when I plug in 0, I get out 3. So this is my y-intercept. When I plug in 0, I get out 3. Meaning, if I take my equation here, and I plug in 0 for my x's, and it has to be for both x's, my answer should equal 3. So let's do this math and solve for a. And figure out what the a in front is. 0 plus 1 is 1. 0 minus 3 is negative 3. Positive 1 times negative 3 becomes negative 3. And finally, to solve for a, it says a times negative 3, so I have to divide the negative 3 away from both sides. And these cancel to just leave me with the fact that a is going to equal 3 divided by negative 3, which is negative 1. So This is almost my equation. However, the a in front needs to be a -1. So after doing all that math, I realized that my final answer needs to be negative in front. So this is our final answer in factored form. Meaning that this graph right here, the equation, if I were to take this guy, -1, parentheses x plus 1, parentheses x, this graph right here is the exact same as this graph up here. Which it is, because you see that has the -1, 0, 3, 0, 0, -3 for the y-intercept. See, and then 1, 4 for the vertex. So they are the same graph. But if I didn't have this a in front, look, it would flip it the other way. And it wouldn't be the same graph anymore. The vertex is different. The y-intercept's different. So that -1 in front mattered to get the correct graph, which is why we needed to test one of the points. If I put the vertex in here, like if I put 1 and 4, and a 1 into both these x's and 4 right here and solve for a, my a would have still been -1. So this is the equation in vertex form so far. Same graph, just know I'm doing it 2 different ways. So if I wanted to do it in vertex form, well, I can't use the vertex to check because it's in vertex form already, and that's what I use to put it in this form. So I would have to either use one of the x-intercepts or the y-intercept in order to test if there's an a or not. So why don't I use the y-intercept again? And the y-intercept was that when you plug in 0, you should get out 3 for an answer. So if I take the equation I have so far, and if I plug in 0 for that x, I should get out 3 for an answer. So if I start doing this math, 0 minus 1 is just -1. So I did 0 minus 1 first because the parenthesis tells me to group. What's the next thing I should do? The next thing I should do is square the -1 because of exponents. So -1 times -1 just becomes a +1. So now I just need to keep solving this for a. So what's my next step in solving for a? To get rid of this +4 by minusing it over. 3 minus 4 is -1 equals, and then a parentheses 1, because +4 minus 4 is 0. Now finally, a parentheses 1 just means a times 1, and anything times 1 is just itself. So a times 1 is just a. I could try to divide that 1 over to like make them cancel, but anything divided by 1 is still just the same thing. So a is going to be -1, which just means that in this equation, to be fully done, my final answer in vertex form is going to be this, except instead of just an a, it's a -1. So I figured out what my a was, and this is my final answer in vertex form. And know that it's the exact same graph. Like if I come to Desmos and I graph y equals -1 parentheses x plus, what was it, or -1 squared, and then +4. See how it's the exact same graph? Went in the exact same place. If I get rid of the purple, the black's behind it. So they're the same graph, just written in 2 different forms. If I ask for the equation, I don't care if you do it in factor form. I don't care if you do it in vertex form. And even if you really wanted to, you could distribute either one of these out and multiply it out and give me the final answer in standard form if you'd like. You don't have to do it like this, but you can. Here, let's do it from factored form. If I multiply the middle out, x times x will become x squared. X times -3 is -3x. Then I have to do the 1 times the x to get plus 1x. And the 1 times the -3 to get -3. And then instead of a -1 in front, and then an x squared, but -3x plus 1x becomes -2x. Then -3 at the end. And then my final step for distributing it out is -1 gets multiplied into all three of those. So I get -1 x squared plus 2x plus 3. Because when I do -1 times negatives, they become positives. And so this with the y equals in front would be my final answer in standard form. And again, if I put this into the calculator, y equals -1x squared plus 2x plus 3. See, it's in the exact same spot as the other ones. See if I get rid of it, the purple's behind it. So all three of these are the same graph, just written in different forms. No one cares what form you give us the answer in, unless they ask. If they write the equation in blank form. Otherwise, you can choose. The only last note I'd make is that the y equals in front can also be written as f of x, because f of x means the same thing as y. It's just the more proper version. Let's work through all the rest of the steps for the table. So I have all my key features for my table. But remember this one, I found this one later on. It didn't actually give us this one in the table. We figured it out by moving backwards from the vertex. So let's pretend that I didn't actually have this guy. I can't make anything from the y-intercepts. So then I would have been forced to do it from vertex form. So remember, if this is the vertex, to get vertex form, or to get the equation in vertex form, it's going to be y equals a, parentheses, x plus the h, being squared, and then plus the k. Remember, the easy one's the k. What is k? Is it the x or the y? The k is the y value of the vertex, so I'm going to write minus 4.5 because it's negative. And then what is the h? Remember, the h is the opposite of what this is. So if this is a -2, the h is going to be a +2. Because then when you put -2 in here, it would equal 0. So that's why you always do the opposite. And so now I have it almost in vertex form. I just have to check if there's an a in front. And so to do that, why don't I plug in the y-intercept this time? So I'm going to plug in y-intercept to check for an a value. So the y-intercept says that when x is 0, y should be -2.5. So to solve this for a, I'm going to quickly simplify that this 0 plus 2 is just 2. And then 2 squared is 2 times 2 is 4. So to solve this for the a, what's my first step? I have to add the 4.5 over. So on this side, the -4.5 plus the 4.5 is going to cancel, and I'm just left with the a being multiplied to the 4. And then on this side, -2.5. So -2.5, and if I add the 4.5, I'm left with +2. So now, how do I finish solving for a? Since a is getting multiplied to 4, I have to divide the 4 away to both sides. So that on this side, the 4 divided by 4 will cancel and turn into just the 1a is going to equal. And then 2 divided by 4 is 0.5. 0.5. So my final equation final answer in vertex form is going to be, instead of an a in front, it's a 0.5. Then this is the equation of that table. And remember, I could replace the y equals with f of x. And just to prove it to you, if I were to take this table right here, and so I'm going to plug all the points from that table into Desmos so that I can see all the little dots as they get plotted. So you can't see them all on the graph right now because it's too zoomed in, but here's some of the points from that table. And I'm telling you the equation in vertex form, at least, is going to be 0.5 times x plus 2 squared minus 4.5. And look, if you look, the equation matches all the dots perfectly as it connects to all of them. Even if I zoom out, up here it connected to that one, up here it connects to this one. So this is the perfect equation for this table. And then, yeah, then that was how we found it. All right, for our situation, Linda's on her football field and she kicks the ball and it goes up, and I know the two x-intercepts and I know the vertex, so I could choose to do it from factored form or from vertex form. I'm going to go ahead and take the x-intercepts and do this example from the factored form. Those are my two x-intercepts. The factored form, start it, is going to look something like y equals a, x. And remember to put them in the factored form. Again, you just do the opposite of whatever's in here in the parentheses. So if that's a positive 2, it's going to be minus 2. If that's a positive 10, it's going to be x minus 10. Because when I solve this and make it equal 0, I would add that 10 over to get this 10 here. So this is the start of factored form. I'm going to use and this time I'm going to use the vertex because that's the other thing that we know. So the vertex right now is at 6, 4 to figure out the a value. So if I take my equation, if x is 6, then the answer should equal 4, according to my vertex. So if I solve for this math, 6 minus 2 is going to be positive 4. Then 6 minus 10 is going to be negative 4. Then the 4 parentheses negative 4 means the multiply, and 4 times negative 4 is negative 16. So finally, to solve for a, what do? It's a times negative 16, so I have to divide the negative 16 away from both sides. So on this side, a negative 16 divided by negative 16 becomes 1a. So just 1a is left. Equals, and then 4 divided by negative 16. 4 divided by negative 16 is negative 0.25. Negative 0.25. So if I take my factored form, my final answer in factored form is that the a in front is going to be negative 0.25. Remember, if you wanted to, you could multiply this out to standard form. You could leave it in factored form. It's probably easiest to just leave it the way it is. But that's the general gist of it. For any graph tables or situation, you're going to pull out everything you know. They need to give you at least 2 things in order for you to do it, because you have to know at least the x-intercepts or the vertex to start it out. then you use one other thing, either the y-intercept or whichever other one they gave you, in order to figure out what your a is, and then you can put your final answer as an equation in that form. So, using the vocabulary words quadratic, parabola, x-intercept, y-intercept, vertex, and then horizontal shrink/stretch, what did you learn how to do in this lesson?